I just wanted to check in with you all regarding using Maple and let you know how to find, access to Maple remotely. So when I was in the class drive folders, our 273 class drive folders, and this may also work for 285, but there's going to be a Maple folder. And in that Maple folder, there is a virtual desktop guide. That's what you're going to want to open, and that's going to show you how to get working with the virtual desktop and how to open the Maple software remotely. So those steps are all in there. You go through, you're looking to open Maple on your computer. Now, I have already gone through here and I'm going to talk about these Maple commands for plotting surfaces. And I've opened a file that's different than what is posted. This one's posted on your lab. But one thing we want to talk about when we're dealing with Maple, we want to make sure that we're using the correct input. I prefer to have mine come in as Maple input. That's this red Courier font here. And whenever you're typing a command, you need to make sure that this little, right pointed bracket here is showing, because without that, Maple doesn't know it's a command. So this little piece right here in front of restart. If you're dealing with Maple and you're having a hard time making it work, something you can always try doing is restart. So I'm going to hit restart, and I'm going to load this command with plots. So I'm just going to hit enter on those. Those are both on the same line. And you'll see we got all of this information loaded. These are all the different types of plots. And for these quadric surfaces in this exact problem, we're going to be using implicit plot 3D. And you can see that that loaded up here in those commands. Now, notice there's a semicolon at the end. If you have a colon at the end, that's going to suppress that information. So a semicolon is going to display the information. All right, so I'm going to enter the function. I'm going to title it F1, and colon equals is important to calling it a function. If I just use an equal symbol, it's not going to know that I mean that this is function F1 and it's titled. Maple is very sensitive to how you type things. So notice when I want to put that exponent, I use a caret symbol and a 2. And you'll see later on down here, I'm sure somewhere, like if you look at F6 down here where I'm highlighting, notice I wanted to say 4y squared. I want you to make sure that you notice how I have typed it 4 times y to the second power. So Maple is very literal. It's going to want to see all those commands. So back up to F1. I've titled it F1. I've identified it as a function, colon equals, and F1 is z minus x squared plus 1. So I'm going to hit enter. And it's going to show me an output here. This is what F1 is. Make sure it looks like what you expect. Again, if I didn't want that output to be shown, if I want to suppress it, I could type a colon and it still knows what F1 is, but F1 is no longer displayed. So I hit a semicolon, enter. Then I want to implicit plot 3D. Notice there are no spaces. Maple is case sensitive. I want to plot F1, and I've said my X values are going to go, and I've put extra spaces in here the way I typed it, but X, my domain span, is -1 to 5. Y, my Y, or we think about that as range span, is -1 to 5. And then my Z values, this 3D aspect, this is new, so it's not quite domain and range, but Z is spanning from -1 to 10. So this is going to graph this for me. So I hit enter. It shows me this image here, and I can turn the image around and look at it as I see fit. Now, this might not be the best view for this. If I hit enter, it's going to, just rerun through that again, and we'll talk about the different types of plots there are. But notice my X is here on the front, Y is there on this side, and then Z is going from, you know, -1 to 10 on this side, -1 to 10. You can see that right there. Z. Now, it looks like in order to get this full graph, I'm going to need to see more on my x-axis. So I'm going to have my x-axis go from, say, -5 to +5. And now you can see the entire quadric surface is graphed. So you're just going to want to make sure that when you're graphing it, you're paying attention to your box window there. And you may need to set that to create the graph as you want it displayed. All right, so scrolling down, here I've typed text. My T, text command, brings up a text box versus the input command, you see it brings up that. We'll just undo both of those. So we do have a few things that will clean it up. The default axes that we see up here are called normal. I'm going to just run through F2 through F6 and show you some different styles and labels and, you know, the way that we set up those boxes. So F2 is y squared plus z squared minus 1. Looks like this. And you notice for my implicit plot 3D, I've plotted F2. My x goes from -3 to 3. My y goes from -5 to 5. And my z value goes from -2 to 2. Now again, I put extra spaces in here just so it's easier for you all to read. So then I have a comma between each of those. F2, comma, my x span, comma, my y span, comma, my z span. I said I want my axis to be as normal, which is kind of my preference because then that centers it at the origin here rather than that box from above. I want it to label them as, you know, you can see the X is kind of hidden. There's X, Y, and Z right there. And then my style, this is just a different style. This is an opaque wireframe, whereas up here, this is the default style. Okay, so let's move on down to the next one, F3. So F3, I'm going to title that. Remember to use your colon equals. And I have z minus x squared minus y squared. And then when I do my implicit plot, I'm going to implicit plot F3. X spans from -3 to 3. Y spans from -4 to 4. And z from -2 to 2. Again, I prefer my axes as normal as opposed to that box. And I'll label my x, y, and z. And in this case, my style is going to be a surface contour. So here you can see those surface contours. We have a elliptical paraboloid, right? Top half of it. All right, let's see. F4, y squared minus x squared minus z squared divided by 4. Just the z squared is divided by 4. I've got my, my box range. In this case, we're going to have frame axes. And again, that style is going to be surface contour. So it's going to show those contour curves. All right, so there's this. And you might want to play around with, you know, how much is showing. Maybe on my X, I'm going to say 50 to 50 here. Oh, that was the wrong one. Sorry, up here we'll say 20. I'm going on the fly with you guys to 20. My X's are going from 20 to 20. It changes it just a little. You know, that didn't really give us information. I think that was interesting. But you guys can, you know, work through this, and I want you to think about scaling your axes appropriately. All right? Let me put this one back to the way I had it. 25, 25. So F5, my fifth function, my fifth quadric surface, I should say here, is identified with the colon equals, not just an equals. Z minus y squared. Y squared is divided by 4 plus x squared, which is divided by 9. Now you see there is a colon here. It's suppressed at the end, my image. So I'm going to put a semicolon, and now it is showing me this saddle. Okay, these are called the frame axes, and again, This plot is using surface contour. You don't have to change the style or the axes, but some students, it's their personal preference to do so. All right, the last one, remember, Maple is going to be operator and case sensitive, so F6 is 4x squared, 4 times x to the second power, plus 4y squared, 4 times y to the second power, plus z squared plus 8y minus 4 times z plus 4. On this one, I changed the font on my axes. It's a wireframe opaque, and we're going to use those boxed axes. So there's my function. Now I will unsuppress that. And here's what it is showing me. I just want to give you a little bit of idea of the way Maple works. This is kind of what I go over with my class when we do it face-to-face. Please let me know if you have any questions. I'm just going to expect you to be able to type a function in and plot it with reasonable axes. So I want you to have it scaled appropriately. Again, if I had to have my z, I don't really need to see down to -4. Maybe I only need to see down to z equals -1. So that scales it a little bit different. Looks like my y's, I maybe only need -3 to 1. And so we can change this, and the graph is going to change based on how you change those axes. Looks like my x, I maybe only need -2 to 2. And so I'm just looking at the picture and I'm saying, okay, well, here we go. It's not a sphere, it is a ellipsoid. But that's what we have. So when I ask you to do some of this Maple on home, you're just going to want to open up your remote virtual desktop, log into it, open it up, and then you can open this file and you can create your own file. When you're creating a file, I just want to emphasize the difference between a text input like this. See, I have a text input right there. That's coming from clicking the T versus a Maple prompt. Okay, so the Maple prompt, when I hit that, that's going to put this little sideways pointed bracket there, and that means I'm inputting a command. Can't think of anything else I would want to tell you right now just looking at this. Please let me know if you have any questions. There is, when we go to that Maple folder, there's a PDF that talks about document mode versus worksheet mode, how to type in Maple, make sure you're typing all of those operators. Capital P gives you the number pi, lowercase p, when you write pi, is going to give you the symbol pi. There's a lot of information in there, but if it's not working the way you want, more than anything, it is a typo, and the computer is going to do the correct calculation given the correct inputs. You have to make sure that your inputs are in there correctly. So there's some basic Maple commands. There's information about how to log in using that virtual desktop. Here's another basic Maple cheat sheet. This has it kind of all on 1, 2 pages, 3 pages, 4 pages, right? But this is one I found that was kind of a little more succinct and had all of the information. It talks about the difference between defining a function and defining an equation, and then how the colon equals assigns a variable some sort of value. And if you've ever gotten too much information in there and you don't like what you have, again, you can use that restart command. One last thing, back to Maple. I really like to set up, let's see, where is it? Tools, options. So I'm old school, I've been doing this for a long time. I've been using Maple since the 90s. And I really like my input to be Maple notation. Okay, and that's going to revert to this Courier font because I'm very literal and I want to see all of the different operators showing up, and I can space it out and add spaces in there as need be. So I hope that makes sense, but I keep mine, and you can apply it to the session or you can apply it globally. Once you click that, then every time you type this, it's going to show up as that 2D Maple input is kind of the way it's referred to as, okay? So yeah, it was a quick, dirty video because I just wanted to make sure that was out there for you, and I'm going to end now. Please let me know if you have any questions.